Hello all. So this is the model question paper. Try to solve the paper. Okay. First question: obtain the DFA to accept strings of A's and B's having odd number of A's and even number of B's. Okay. They are asking odd number of A's, that means 1, 3, 5, and even number of B's, that is 2, 4, 6. Okay. And this question from module 1, modulo K counter problem. They may ask any combination like even number of A's and even number of B's, or even number of A, odd number of B's, or odd number of A's, even number of B's, or odd number of A's and odd number of B's. So in this question they are asking this odd number of A's and even number of B's. Okay. First I am starting from a state, call it as Q naught. Okay. So let me take an example. Okay, I am taking A and 0 B's. Okay, there is no B, epsilon B. Okay, 1A is an odd number, I need to accept this, right? So 1A, I am going to accept this. Correct? Double circle means it going to accept. Next, what if it is 2A comes? Then I need to reject, right? So if 2A comes, then I am going to reject this. Okay, this is not accepting state. Next, suppose it is like A, B, B. Then here also odd number of A is there and even number of B's are there. So 1, 2, 3. Okay, odd number of A's is accepted. Then what about B? It need to be accepted, right? I write here Q2. Okay, then here is an accepting state. Next, what if it is A, B, B? It need to accept or reject. Here even number of A's are there and even number of B's are there. So it need to be reject, right? So first 1A comes, 2A comes, next another B comes. I will write it as Q3. Next one more B is there, rejecting. Okay. Next consider an odd number of A's, that is 5A, next to 5B. Okay. So first you consider B's, 5B's, next you consider 5A's. Okay. This also need to be reject because odd number of A's, odd number of B's are there. So 1B, 2B, 3B, 4B, 5B. After that 5A need to comes. So that's why 1A, here 2A, then 3A, 4A, 5A. This is also rejecting case. Okay. We tried all the case, that is even A, even B, even A, odd B, odd A, even B, odd A, odd B. Okay. If they ask odd A and even B, then your final state is this. Okay. If they ask even A, even B, then your final state is gonna be this. Okay. Next is odd A, odd B is the final state is this. Okay. This is the final state for even A, even B, and this is the final state for even A, odd B, and this is the final state for odd A, even B, and this is the final state for odd A, even B. So better to write like this. This is even A, even B. Next this state is even A, odd B. Next this is the state for odd A, even B, and this is the state for odd A, odd B. Okay, and this is the final state in this case. So question number 2, draw DFA to accept decimal strings divisible by 3. So in the question they mentioned decimal, that implies that this is the question from divisible by k problem. Okay, there may ask two type of problems. If they decimal, then your radix becomes 10. If they ask binary number, then your radius becomes 2. Okay, in this question this is decimal, so r is 10. Okay, then what are the input alphabet? This is the radius. Next, what are the input alphabet for this? That is 0 to 9. Okay, 0, 1, 2. If they ask in binary, then r is 2, then what are the input alphabet? That is 0, 1, 2. Okay, next in this question, and they are asking divisible by 3, so divisor, that is k, is nothing but 3. Okay, they may ask divisible by 4, divisible by 5, and the solution for those questions are already available in module 2 divisible by k problem. Okay, and this is the step number 1. I mentioned stepwise solution also. Okay, and in the step 2 we need to find what are the possible remainder. Okay, possible remainder. So what we have, 0 to 9, these are 3, 4, 5 our input. So when we divide by 3, so on, what are the possible remainder we need to find. Okay, so 0 mod 3 means 0, next 1, next 2 mod 3, 2, next 0, next 4 mod 3, then the remainder is 1, 5 mod 3, remainder is 2, 6 mod 3, remainder is 0, 7 mod 3, remainder is 1, 8 mod 3, remainder is 2, 9 mod 3, remainder is 2, 0. Okay, next what are the possible remainder here? That is nothing but 0, 1, 2. Okay, next we need to represent in the state, that is q0, q1 and q2 state. Okay, there are 3 states are there. Next, in the 3 state we need to mention the 9 input alphabet. So we are grouping in such a way that the remainder 0 is one group, that is whatever remainder 0 gives na, then we group it together, 0, 3, 6, 9. Next, for 1, 4, 7 the remainder is 1. Okay, next 2, 5, 8 are grouped together as 2. Okay, this is the step number 2. Next, go for step number 3. In the step number 3 we need to take a column. Okay, first we need to mention the remainder, what are the remainder, and in the second step we need to write the input alphabet, and the formula for divisible by k problem is r into I plus d mod k equal to j, and qi d equal to qj. Okay, remainder is, we have 3 remainders, that is 0, we have 1 and we have 2. Next, d is 0, 1, 2, and note that in 0 means it comes 0, 3, 6, 9, 1 means 1, 4, 7 and 2 means 2, 5, 8. Okay, if we not group together, then we need to mention 0 to 9 for each, so which is hard, right? So we make it simple, 0, 1, 2, 0, 1, 2. Then apply the formula here. R we have 10. And what about I here 0. Next, what about D? 0. Mod K means how many? Divisible by 3, right? So it is 3. So finally 0 mod 3, 0. Okay. Apply the same, like R is every place, that is 10. Next, Here I is 0 and here I is 1 and here I is 2. Next 1 2. Here is 0 1 2. Next 0 1 2. Next all is mod 3. So everyone is mod 3 here. Okay. Next here 1 mod 3 1 2 mod 3. Next 2. Next here 10 plus 0 10 mod 3. Remainder is 1. Next 12 mod 11 mod 3. Remainder is 2. Next 12 mod 3. Remainder is 0 and here 10 into 2 20 mod 3. Remainder is 2. Next remainder is 0 here. Next remainder is 1 here. Next what is Q? I 0, then D is 0, then the final state is Q 0 here. In the same way Q 0 1 here, Q 0 and 2. The final state is Q1 Q2, Q1 Q2. Next here Q1 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 from 0 1 2 and the output is Q1 Q2 Q1 Q2 Q0. Here is Q2 0 1 2 Q2 Q0 Q1. And for this column we need to write the diagram. Okay, so take a Q0 as a start state and the final state is Q0 itself because we need remainder is 0. Okay, I am starting from here Q0. So in the Q0 state, what if 0 comes, it goes to Q0 itself. Okay, 0. Next 1 comes, then it goes to Q1. One here, it goes to Q1 and 2 comes, then it goes to Q2. Here is the 2, then it goes to Q2. Okay, and Q0 is the final state itself. Next in the Q1 0 comes, then it goes to Q1 itself. Next 1 comes, then it goes to Q2. Okay, next 2 comes, then it goes to Q0. In the Q2 state, if 0 comes, it goes to Q2. Next in the Q2 1 comes, it goes to Q1 and in the Q2 if 2 comes, then it goes to Q1 state. Okay, and we know that 0 means it consists 3 6 9, correct, and 1 means 1 4 7 and 2 means 2 5 8. So write the same for all. So this is the final diagram. Next 1C is define the following, that is alphabet, power of alphabet, language. I will give the solution in the PDF and because it's a theory question. And 2B also define a DFA and explain the 2 preferred notation. This also I give in the solution. Let me solve this. 2A, that is obtain Epsilon NFA to accept strings consisting of zeros or more A's followed by 0 or more B's followed by 0 or more C's. Okay. While writing Epsilon NFA, we can't make initially Epsilon. Okay, so I start from here, more A's. So this is the Q0 state. then I need to accept more number of A's, 1A or more A's, that is 1A or more A's, then followed by 0, that means epsilon. Next one, epsilon means 0 and more number of B's, followed by 0, that is epsilon, and more number of C's, that is see here, and this 0 I am writing in the final state. Okay, epsilon zeros or more is Q3, this is the final state. Here Q3 is a accepting state and Q0 is to accept 0 or more is. Next this is for 0 or more B's and this is for 0 or more C. Next question is 2C, that is lazy evaluation method. It consists of 5 steps. In the first step we write the number of states, that is starting state of DFA or starting state of NFA is nothing but what here, Q0. Okay. Next, in the second step, mention the input alphabet. Input of DFA or input of NFA is nothing but 0 and 1. In the step number 3, we need to do NFA transition table, correct? So, 0 and 1. Q0 is a start state, Q1 and Q2 is a final state. Okay. Q0, if a 0 comes, then it goes to Q0 and also Q1 because this is NFA. Next, for Q0, if 1 comes, then it goes to Q1. Next here, Q1, 0 comes, it goes to Q2 and 1 comes, it also goes to Q2. And in the Q2, if 0 comes, then there is no transition. Okay, and 1 comes, then it goes to Q2 itself. Okay, this is the step number 3. In the step number 4, we need to write a DFA transition table while watching NFA transition table. Okay, since it is lazy evaluation method, we write only the required states, but in the subset construction method we need to, if there is a 3 state, then 2 to the power 3, 9 states are required, right? But in DFA transition table we write only the required states. Let's see. First write the table, NFA transition table. Okay, we start from Q0, 0 and 1. Here starting state is Q0 and Q0, Q1 and here Q1 is there. Okay, next we need to check all these states are here or not. So write the Q1 here. Okay, Q1, next this is Q2 and Q2. So next write Q2 state, Q2, that is Q2. After that write this done, this done, this done. This is the remaining, right? So write Q0, Q1. Okay. For Q0, Q1, Q0, Q1, if 0 comes, we write Q0, Q1, Q2. Q0, Q1, Q2. Next, what if 1 comes for Q0 and Q1? That is Q1 and Q2. Q1 and Q2. So in the next step, write this Q1 and Q2. Q1 and Q2. If 0 comes, then it goes to Q2. And if 1 comes, then it goes to Q2 only. This done, remaining is this one. Q0, Q1, Q2. Okay, Q0, Q1, Q2, 0 comes, Q0, Q1, Q2 side. Q0, Q1, Q2. Next, what if 1 comes, Q1 and Q2. Q1 and Q2. Okay. So next Q0, Q1, Q2 is done and Q1, Q2 is already done. You need to check this side is also present this side, okay, in the transition state. Next here Q2 is the final state, and here also Q2 is there, here also Q2 is there. Okay, then for this we need to write the diagram, and that is the step 5 transition diagram. First write the Q2 starting state, that is Q0. Okay, if 0 comes it goes to Q0 Q1. Okay, for this 1 case it goes to Q1. This state is done. Next for Q1, what is 0 case? It goes to Q2. For this 1 case, it also goes to Q2. Okay, this done, this done. Next for Q2, if 0 comes, it null transition, and 1 comes, it goes to Q2 itself. Okay, this state is done. Next for Q0 Q1, if 0 comes, then it goes to Q0 Q1 Q2. Okay, if 1 comes, then it goes to Q1 Q2. For this state, if 0 comes, it goes to Q0 Q1 Q2, and 1 comes, it goes to Q0 Q1 Q2. Next for this one, Q1 Q2, if 0 comes, it goes to Q2, and 1 comes also, it goes to 2. This is the final answer. Next, 3A is again a list application of regular expression and notation used in Unix operation. This is theory question. You can read from the PDF. Okay. Next, obtain Epsilon NFA for regular expression a plus b whole star bb, again a plus b whole star. To solve these kind of questions that convert into Epsilon NFA for the given regular expression, we need to know 3 steps. Okay, first one, if r plus s, this means a plus b here. Okay, if this comes, then we need to introduce 4 epsilon. Okay, and this is epsilon. Okay, then here is a start state and here is a final state. And the second thing you need to know is r. Okay, r into s. R into S. In this case, how to combine this? R here, S here. Then with the help of epsilon, we need to combine. Okay, epsilon, 1 epsilon in this case. In this case, 4 epsilon. What if R whole star? Okay, that means it implies that R is here. R is here. Next, we need to introduce epsilon and 1 more epsilon here. Okay, and from here to here epsilon, and a new start state and a new final state here, and from start state to final state, totally 4 epsilon in this case. Okay, this is the 3 things we need to know. First is we solve part by part. First I am taking a plus b. Okay, a plus b. So this is start state here, and epsilon. This is a. Next this is b. Next again epsilon, and this is the final state. This is for a plus b. Okay, we introduce 4 epsilon and a and b, a start state and a final state. Okay, next what we will do, a plus b whole star, take this much. Okay, whole star consider, a plus b whole star. If the whole star comes, then we need to introduce a new start state and a new final state. Okay, here I introduce a new start state with the help of epsilon, and the same a plus b here. Here is A, here is B. Next, a new final state with the help of epsilon. Then from this to this epsilon, and from this to this one more epsilon. Okay. Next we need to multiply B here. Okay. How we multiply, I will write in this case only. Okay. Here is my A plus B whole star. For this I need to multiply B. So with the help of epsilon I multiplied B. Okay. Next one more B. B also B is multiplied here. So with the help of epsilon I write one more B. So epsilon and B, next again epsilon and B here. Okay, this is for A plus B whole star into BB, then again multiplied with the A plus B whole star. So I made it A plus B whole star again. Okay, see, first A plus B whole star into B, again we need to multiply with the A plus B whole star. So remove the final state. Okay, how we multiply? With the help of epsilon, correct? So for this state we are combining this with the help of epsilon. This is the answer. Next one is a 3C, that is a construct to minimize a DFA. So this is the given question and it consists step by step process to solve. Let's solve this. Okay, so we need to write the marking table. Okay, so this is the table which looks like this. From here we remove the A, start from B, C, D, E, F, G, H. Okay, from this side we remove the last H1 and A, B, C, D, E, F, G. This is the method to follow to construct a table. We follow this method. Okay, initially A removed here, here H removed here. Okay. Next we need to mark the table in such a way that first look at the final stage. So here D is the final accepting state. So mark it every row and column of D. Okay. Next we need to write the transition and input. Next write the table. How to write the transition? See here A. So wherever the blank is there, A, B, A, C, A, E, A, F, A, G, A, H. For B, it is B, C, B, E, B, F, B, G, B, H. And in the same way, write for all. For G, we have only one column, that is G, H here, G, H here. Okay. Upon 0 and B gives what? B and A. B and A. Upon 1, it gives what? A and C. A and C. Next for A and C, for 0 it gives B, D. For 1 it gives A and B. Next A, E gives B, D. Next this gives A and F. Next here B is common. Here A is common. Next F gives G, G gives F, H gives G. Next again F gives E here and G gives G here, H gives D here. Next for B and C, upon A it gives AD, upon B it gives C and D. Next B, E, B and E, upon 0 it gives A and D, upon 1 it gives C and F. In the similar way complete the table. Okay. Next from this table start to mark here. How to mark? First look for BA. BA, is this marked? No. Next AC, A and C, is this marked? No. Okay, next B and D. B and D, it is marked. So we need to write AC in the marked state. Next B, D again. Next we write A, E also. Okay. Next here BG is marked, no, AE is marked, AE is marked, and in the first iteration go for D only, okay, search for D. Here AD is there, mark A and H also, okay. In the A we marked AC, AE and AH. Next in the BC search AD, A and D marked here, again A and D marked here. After that here C and D is there, mark BC, BE and BH, BC, next BE and BH, okay. After that in here it has DD, so there is no D here, so after that DG or DG, DF, DG, DF, DG, okay. Mark everything, CF, CG, CH. So mark here CF, CG, CH. After that go here D and G, D and G marked here, DG marked here, D and F also marked here. So EF, EG, EH make a mark, EF, EG and EH, and here E and D is present. So make a mark on F and H, F and H. Next here DG, so G and H should be marked, okay. In the next step what you need to do is write the remaining only, okay. Here we have 1, 2, 3, 4, 5, 6 and 7. Rewrite again, so I will erase and rewrite again. So this is the rewrite table. So find again is there any marking or not. For BA it is unmarked, and what about A and C? A and C is marked, so make AB. Is any one is marked, then this is also marked, okay. Next for BG unmarked. What about A and E? A and E here is marked, so make a mark on A of 1 also. Next B and F is unmarked, and what about A and G? A and G is also unmarked, so in A make AB and AF as a marking state. Next A and G is unmarked. What about C and E? C and E also unmarked. Next A and F is marked, so make BG also a marked. Next G and F, so here F is here. What about E and G? E and G is marked, so make a mark on F and G also, F and G, okay. Next DD is no state and BF is also. What about B and F is unmarked, okay. So this is the table. And next what is remaining? AG, BF, CE. Write again in the next step, okay. We need to rewrite again 0, 1, and the remaining is now AG, BF, okay. I will write here 0, 1 and remaining is here AG, BF and CE, that is BF, AG, CE, and for CE it is DD and BF, okay. Check again is there any marking again. So B and F is unmarked, and A and G is unmarked, A and G unmarked, C and E is unmarked, D is unmarked, B and F is also unmarked. So this is the final answer, okay. This is the final remaining things, and from this we need to write a transition diagram, and also between them there is one step, that is we need to find distinguishable and indistinguishable state. Indistinguishable Okay, distinguishable means here dth row and dth column is filled, right? So D is a distinguishable, and find any other state where both row and column is filled. Here H is filled in row, okay, and there is no H column, so consider H also a distinguishable table, and for A here is remaining, and for B here is remaining, C also remaining, and D is already distinguishable, and for E in the column in the row there is empty space, it can't be a distinguishable, and for F also and for G also remaining, so distinguishable are only the D and H. And what about indistinguishable means AG, next BF and CE, the remaining state are AG, BF and CE are the indistinguishable state. Okay, after that we need to construct a transition table. First we need to write DFA table, that is nothing but transition 0 1, and states are AG starting state, okay, because A is the start state here, after that BF, after that CE, next write the distinguishable state also AF and BF AG, next don't write twice, only write one time, okay, AG CE BF, and for D if 0 comes it goes to D itself, and 1 comes it goes to A, and for H it is G and D, and remember one more thing, we can't write A singly because we write this state itself, that is AG, and here also this is AG, and here D only. For this we need to write the diagram. This is the table, and here final state is D. Next to write the DFA, okay, here AG is a starting state, okay, if 0 comes then it goes to BF, B comma F, okay, next if 1 comes it goes to AG itself, next for B and F if 0 comes it goes to AG, and if 1 comes it goes to C and E, next for CE if 0 comes it goes to D state, if 1 comes it goes to BF, next for D if 0 comes it is a self loop and D is a final state, and if 1 comes it goes to AG, next for D if 0 comes it's a self loop and 1 comes it goes to AG. Next for H if 0 comes it goes to AG, and if 1 comes it goes to D. Okay, this is the final diagram, and now the board is occupied by this guy, and let's take a break, we will continue this, okay. ಇವತ್ತಿಗೆ ಮುಗಿಬೋದಾ? ಮುಗಿಲಿಕ್ಕಿಲ್ವಾ ಅಂತಲ್ಲ ಅಹನ್ क्या है बाबा? अरे सहन गुड बॉय पिरोडग ओरेसला Rohan, please. ಅವು ಮಾರ್ಕರ್ ಹತ್ತು ಮಗ ಇಟ್ಟು ಪೋಪುರಿ ಹೈಲೈಟ್ನರ್. Next question, that is 4a, define pumping lemma, prove that below language is not regular language. Okay, so L is a power I b power j, where I greater than j, not regular. Define pumping lemma means write this much. Okay, that will be a regular language. There exists a constant k such that for every string w in the language such that the length of the string is greater than k, and we can break w into 3 strings. In the not regular we break into 3 strings. If they ask not a context free, next we break there into 5 steps. Okay, and write the condition. For this we solved the same, that is a power n b power m, where n greater than m, correct? But here they asked a power I, only they named changed the name. Okay, so w means here I is always greater than j, right? So we add 1. Next b power k, w is count of k is 2k plus 1, 1k, 2k and 2k plus 1 here. Okay, this is the step number 1. And step number 2, let k be 3, then this becomes a power 4 b power 3. Next, break the string into 3 pieces. You can break anyhow, so I breaked this a with x and this is y and the remaining is z. Check the condition. Okay, xy is less than k, here length of x and y, here is 2 and here is 3. Okay, total is 3 and k is 3, so this condition is correct. Next, y not equal to 0, here y is 1 and it is not equal to 0, and in the third step we assume q equal to 0. Next, here x, y0, z, y means a. Next it becomes a3 b3, but what we need to get, we need to get a4 b3, but here I and j is the same, but the condition given is I should greater than j, correct? So this is not belongs to the language, which is contradiction to our assumption, correct? So the L is not regular. Next, accept A's and B's. Okay, the question is 4b. Develop regular expression to accept the strings of A's and B's whose fifth symbol from the right end is A, and accept strings of A's and B's containing no more than 3 A's. Okay, first fifth symbol from right end is A. This is first place, second place, third place, fourth place, fifth place is A. Right end is A. Next, in the first place it may be any number of A's or B. Here also any A or B. Here is also any A, because input is A and B, right? Here also any number of A and B. And in the fifth position it is a A. Okay. After that it is a star, because multiple number of A or B may come. So this is the regular expression. Next, no more than 3 A's. Okay, regular expression for that. First, no more than 3A means there may exist an epsilon A, correct? 0A is also allowed here, or else A into A, 2A. Next, here multiply this becomes 3A, correct? Next, 3A is fixed, no more than 3A. Next we have B, right? So in the beginning there may be any number of B's. Okay, here also this is the solution. Next question is 4C. Find a regular language accepted by the following by state elimination method. Okay, next, this is the given question. Okay, while applying the state elimination method, in the first step what we need to do? We need to check if a new start state or final state is required. Here from q naught there is a incoming edge also. Okay, so that's why we need to create a new start state, then it goes to q naught, then it is 0. Okay, next we need to check whether the final state is required or not. New final state, here to accepting state, right? So we need to create a final stage. Okay, 1 and q1. Here is a self loop of 1. Next this is 0 and this is q2 and 0 1. Then we need to perform eliminating the state one by one. After that we need to find the final solution from start to final state. Okay, consider if I am performing removing the final state, that is q2. Even though if I remove this state, it can't come back. Okay, from 0 it goes like this, 0 and self loop of 0 1, it not coming back to q1. So there is no language accepted by q2 because it's not coming to the new state, correct? So I simply remove the q2 state. Okay, remove q2 because no new coming edges here. After that I perform, okay, this q2 state is deleted. Okay, next check for q naught. Okay, what happens if I remove q naught? Epsilon here it goes the same, 1 q1 and self loop of 1. If I removed here q naught, then here is a 0 star. 0 star means multiple number of zeros and it goes to epsilon. Okay, next here is the final state. This is one way to reach the final state after removing q naught. Next, in the next step we need to remove another state. Consider that is a q1. Okay, what happens if I remove q1? I will write here. Okay, s is here and here is the final state. Already I have 0 star epsilon. If I remove q1, then becomes 1 epsilon 1 1 star, that is 1 . Okay, sorry, one more thing is left here. If we remove q naught, one step is like 0 star and epsilon for the final state, and also here along with the 1 we have 0 star, right? 0 star 1, next 1 here. In the next step if I am removing q1, then it becomes what? 0 star 1 and again 1 star. Here 0 star 1 and 1 star. Okay, next to get to the final solution, what is the final regular expression? I need to add, because here 2 are there, I need to add both and 0 star. Okay, 0 star take outside, then we get what? Epsilon here. Okay, 1 star plus epsilon. Okay, next 0 star, next 1 star is the same as 1 star plus epsilon, and the final language is 0 star 1 star. Okay, this is the solution. Next question is a 5A. What is ambiguous grammar? Explain the technique you for reducing ambiguity in the grammar. This is the theory question, leave it. Okay, I will give solution in the PDF. Next one is show the following grammar is ambiguous by taking the string AAB and they given the grammar. Okay, when they say to show it is ambiguous or not, remember one thing, that you need to find two different parse tree by applying the LMD twice or RMD twice. Okay, I am going to apply LMD twice, so you can perform with RMD also, okay? LMD1, I am taking S, okay, the given string is AAB, okay? A, I am starting with here, AS, next A, I need another A, right? And after that I need B also, so in the place of S, I will apply A, S, B, S. Okay. After that, A in the place of S, epsilon. Next, B, S. A, epsilon, B, epsilon. Next, S gives A, B. Next, I am going to apply same LMD twice and start from this one, AS, BS. Next, A. In the place of S, I will substitute AS, BS. Next, AA, epsilon, BS, AA, B, epsilon, AAB. Now, for both of these, write a parse tree, okay? For this LMD1, the parse tree becomes S gives A, S, and here AS, BS, S is replaced by epsilon, epsilon. For this, S is AS, BS, next S gives AS, S is replaced by epsilon, and here S is replaced by epsilon. Next, mark in circle AAB, AAB, and you can clearly see from the main branch there is a two sub branch in this parse tree, but in this from the main branch there is a four sub tree. So we can say that the two parse tree are different. The given grammar is ambiguous. Okay. Next to question 5c, write CFG for no more than 3a and any number of a's and b's with at least one a. Okay. So first question, no more than 3a means in that case we have 1a. I will start from here. Okay. Yes, gives. It may be 1a or it may be 2a or it may be 3a. Okay. No more than that. So in this there may be any number of b's. Here in this case also from start, middle or the end any number of b's may present. Here also any number of b's, and this implies that only b there is 0a. Okay, 0a, 1a, 2a, 3a, and no more than that. What b implies is that any number of b's start with epsilon. Okay, 0b or any number of b's, which implies this. After that 1a, 2a, 3a, in the middle any number of b's, middle, end or start. Okay, any number of b's. This is the CFG for that. Next question is any number of a's and b's with at least one a. Okay, so for any number of a's and b's, we write what? S gives any number of a's or any number of b's. Okay, start with epsilon, maybe 0. For at least one a is like that, any number of a's with at least one a. They added both, right? So the grammar, the final CFG looks like S gives any number of a's with at least one a, where a representing any number of a's or b's. Okay. Next question is 6a. For the below grammar, obtain the PDA, and this is already solved while solving the module wise important questions also. It comes under equivalence between CFG and PDA. Okay, the same question they given the same question. Okay, to convert between equivalence CFG and PDA, we need to you need to know the two step, that is start step and final step. So remember in the q naught, that is the initial stack state. Okay, and there is empty and input alphabet represented by z naught, where initial state here, and it changes the state to q1, and after that in the stack top we have sz naught, and for the start state and for the final state we represent qf. Okay, we need to write this step 2, that is production of cfg and transition of pda. So production of CFG means nothing but write the question again, but what the changes you need to do? A gives AB, again write A gives another A, next B gives BA and B gives B, next C gives A. Okay. Next need to write a transition of PDA, that is nothing but here the state is Q1, and what is the input? Start input is A, and in the stack top we have S. Okay, starting state. Then what is the remaining? State is Q1 itself, remaining what? ABC. Here it is Q1. Okay, for this state is Q1 and here input is A and produced by A. State is Q1 itself and remaining is B here. Okay, for this Q1 and A produced by A, here is Q1, remaining is nothing, epsilon. Next transition Q1 B produced by capital B and Q1 remaining is A here. Transition Q1 B, next Q1 epsilon, next Q1 A C, Q1 epsilon. After that, if you need to write diagram, then just mention it, no need of that still. Okay, the transition diagram looks like Q0 and the final state is QF, Q1, and here that is epsilon Z0, S Z0, and epsilon Z0, Z0. The transitions are, if A, then produced by A, B, C, you write all these. Okay. Next, if it is A, next it is B, next if it is A, also it gives epsilon, next after that B, it gives epsilon, A and also B for epsilon and A, C for epsilon, this much. Okay, this is the transition diagram, and this is the step 2 is the main step in this case. Okay, next question, for this grammar using this string we need to find a derivation tree, nothing but parser tree, then LMD, RMD. Okay, first let's go for LMD. S gives I require A here, so I should to start from AB. Okay, next this is leftmost, after that, okay, what I require A, again AB, so B gives what? I should go for this one, A, B gives what? A, B. After that I require B, so that A, I will substitute B, B here. I am substituting from left side. Okay, another B is here. I need B, so I will substitute this B S. Okay, S gives B. After that I require A, so in the place of S I will substitute B. S gives B, A. In the place of B I need to substitute what? BS. A done, B done, again AB I require, so B. In the place of S I will substitute B, and B. A. In the place of B I will substitute B. Okay, we start from left side and we go on for substituting, and finally we get the required string. Now perform rightmost derivation. So S gives, in the beginning I need to write A itself, right? A, B. After that I am going for right side for this B, right? A, I will, B can substitute with the B itself. Okay, B. After that we can change it to right side, correct? B, we will substitute for this B, that is B S. I am focusing on this B. Okay, the B is here. Next B. In the place of S I will substitute AB. Okay, next B. What is next? B. Next in the place of B what I need? I need another B, right? So in the place of B I will substitute BS. S gives B. I require another B here, so B. After that B. In the place of A I will write B. Okay. Next we need to write derivation tree or parity tree. Either you can use leftmost derivation or rightmost derivation of your choice. Okay, I am go for leftmost derivation. AB. Next it will gives B. After that B will substitute by B. Next B gives BS. Next again S gives AB. It gives BS. After that S gives AB and B gives B here. Okay, then mark the B, This is the parity. Next is a 6C. Define CFG and write the grammar for all non-palindrome and 0 power n1 plus n plus 1 and WC WR. Okay, first one is all non-palindrome over A and B. Okay, what you meant by palindrome? Palindrome is nothing but if AB then it is BA, right? And if it is BA then the palindrome is reverse of the AB. Okay, non-palindrome. So we need to write for non-palindrome, right? That means if it is start from A then it end from B. Okay, if it is start from B it should end from A. You shouldn't accept the same, correct? And this case shouldn't match here. And after that in the middle any number of A's and B's it can be acceptable. Okay, so first I am writing if it is start from A then it ends from B here, and in the middle I write a variable which accept any number of A's or any number of B's or epsilon. Okay, and if it is start from B and it should end with A, in the middle I write any number of A's and B's. Okay, and for this case also I will write, if it is start from A and it calls again multiple A or B, and here also if it is start with B, then it is ending with the B, and I am calling S again. I will tell this with the example. Okay, consider if it is ABBA itself. Okay, if I need to write the grammar for this, it is first I write ASA, after that S gives A, I require B, right? So I write BS B and A is left, and we can't substitute anything to the S, so that means it can't derive anything. S can't derive epsilon, correct? So the solution, the grammar is ended here itself, so the given string is rejected. Suppose if it is AB here, AB, it is a non-palindrome, correct? And S gives ASA, after that, okay, here start with A ending with B, ATB, and here T derives any number of A's and B's, so I require B here, B, T, B, and after that A, B, T gives A, T, B, S gives A, B, A, B. Okay. This can be, T is substituted by epsilon and the string is able to accept. But in this case, if it is palindrome, the given grammar can't accept it. Go for the next one. So L is 0 power n, 1 power, start with the 0. What if n equal to 0? So 0 power 0, next 1 power 1, after that n becomes 1 means 0 power 1, 0, next 1 power 2, that is 1, 1, and 2 means 0, 0, 1, 1, 1, and so on. The grammar is for any number of 0, start with 0 and ends with 1, and the base case is 1 here. Okay, this is the grammar. And the next one is WCWR. That means if A is the input, then reverse of A is A itself, C here. B is the input, then reverse is C. Next AB is the reverse of that BA, in the middle C, and so on. So the start from A, it also end from A. If it is start from B, it should end from B also, and in the middle any number of A's and B's, and the minimum base case is C. Okay. Next one is a 7b, which says remove epsilon production and unit production. So first one is epsilon production. To find epsilon production, we need to find null variable, correct? Epsilon is produced by A is a null variable. So if we substitute epsilon here, then small letter A is remaining, S can't be a null variable. And yeah, that's all. A is a null variable. After that we need to substitute. S gives A, B, and in the place of A substitute epsilon, it becomes A. Next A gives A. In the place of A substitute epsilon, it becomes AA. If we substitute here, then also it is AA. No need to write two times. If both are epsilon, then we only get A. Next is a B. So there is no change here. B, C, and C gives caps B. Next they say remove unit production. So what are the unit here? Unit is only B. We need to substitute for here. S gives A, A gives A, B gives BBC, and in the place of B we need to substitute BB and BBC. This is the answer. Next 7C, they will set that what? Define GNF, convert the following grammar into GNF. So the question is out of syllabus. Don't know why they given here, and that too for 8 marks. Define GNF and convert the following grammar into GNF. Okay. So let's solve one question. In the CNF, what we will do, we will need to get either one terminal, that is small letter, or two capital letter, correct? In the GNF, we need to find what? The production should be in the form of A alpha. A should give A alpha. That means one capital letter and alpha represent here variables. Okay. And in this case 0 and 1s are nothing but the small letter, that is the terminal. To convert in the form of GNF, basically we need to follow some step. In the first step, obtain CNF itself, obtain CNF. So question GNF is they asked, first you need to write the CNF, so they may give 2 to 3 marks for that. And second step is rename variable. And in the third step need to substitute and in the final case the output should look like small letter, and after that capital letter. It may be any number. Okay, so first we need to do what? Obtain CNF. First, is there any epsilon production? No. Is there any unit production? Then yeah, here B is a unit production. Okay, so substitute there. A, B, 1, 0. After that A gives 0, 0, A, and B gives 1, A, 1, and B gives 1, A, 1. Okay. In the next, remove mixed production, correct? So what are the terminal here? Mixed production. S gives A, B, and I will represent as A1, then single terminal is fine. Next A0, A0, A. Next A1, A1. After that B gives A1, A1. Next A0 implies 0, A1 implies 1. In the third step, okay, this is the fourth one, remove long production, correct? So S gives A, B, A1 means consider as it a M1. Next 0, A gives A0, M2, A1, M3, B gives A1. Here A1 same, so I will give M3 itself, and A0 means 0, A1 is 1, and M1 means B A1 and M2 means A not A, M3 means A1. If you don't know the CNF conversion, then please watch the module 4 once, okay? Converting into CNF. In the second step, we need to rename, okay? So from S to M3, start from A1, okay? So rename here. Where should I write? There is no need to write here. I write S as A1 and here A2, A3, A4, A5, A6, A7, A8. No need to write here, okay? Second step is renaming. So I need to rename these as A1, A2, A7 and A8. Okay. Next AM1, correct? A means what? A2. S gives AM1 where A means what? A2. Next, what is M1? A6. Next 0. A naught means here A4. Next M2 means A7. After that A1 means A5. M3 means A8. In the same way substitute, okay? A3 means A1, A1 means A5, after that A8, A4 means 0, 1 itself. Next A3, A5, A4, A2, next A2, A5. And what I told, converting into GNF means one terminal followed by alpha variable, okay? Here A4 and A5 consist only terminal, so this is already exist in GNF form, and here after that no one is in a GNF form, okay? And you need to check here 1 compare with the 2 and 6. Here I, here J is here, okay? I greater than J, and here also 2 is sorry, 1 I is 1 is less than 2 and 6, correct? And here also 2 is less than 4 and 7, I and J. Here also 3 is less than this, and here is no need to mentioning that. Here is 6 is greater than 3 and 5. Here is greater than J. So after that we need to substitute the GNF to the wherever it present, we need to substitute. That means A4 gives 0, we need to substitute here, and A5 gives 1, we need to substitute here, in that way, okay? Next, start substituting A4 and A5. I will start from A2 because if in the initial I will substitute for A1, then again I need to substitute. So I will start from here. A4 means 0 and A7. Next A5 means 1, A8. Next in case of A3, A5 means 1 and A8. Next, in case of A7, A4 means 0 and A2. In case of A6, A3 means 1, A8, A5 means A5, correct? After that, I will go for A1 now. A1 means A2, A6, correct? What is A2? 0, A7 and 1, A8. A2. After that, write A6 or else it is 0 and multiply 0, A7, A6 and 1, A8, A6, 0. Fine. Next, remaining is A8. A8 means A2, A5. Again A2 means 0, A7, 1, A8. Next A5. Here I greater than J, right? So A5 as it is. 0, A7, A5, 1, A8, A5. Okay, in the final step, write again, rewrite. A1 gives what? 0, A7, A6 and 1, A8, A6, 0. A2 gives 0, A7, 1, A8. Next A3 gives 1, A8. A4 is 0, A5 is 1 and A6 gives 1, A8, A5. Next A7 gives what? 0, A2. A8 gives 0, A7, A5. 1, A8, A5. This is the final answer and you can cross check one terminal followed by variable, one terminal followed by variable, terminal is fine, one terminal variable, terminal variable, terminal variable, terminal variable, terminal variable, terminal variable. Everything is converted into GNF. Next 8A is obtain LMD, RMD and pass 3 for this. Okay. So first one is LMD. E gives LMD here. We require plus here. So plus EE. After that I require star. So E is substituted by star EE. Star EE and E itself. Next I require minus. So E is substituted by minus EE. And EE itself. Next plus star from X. Okay. Next for RMD same step. RMD plus EE. Next plus in the last what we require? Y, right? Plus E. In the place of E I am substituting Y plus and after that this star EE I require EEY plus star this is substituted by X. Next plus star minus required minus EE XY plus star minus E this is substituted by Y XY and finally plus star minus XY. Next parse 3 I am going to write you can write parse 3 for both, okay, or any one parse 3. I am using LMD. So E gives plus EE gives star EE minus EE. After that xy. 8b question, convert this into CNF. To convert first epsilon production, then remove the unit production, then remove the mixed production and long production. 4 steps we need to follow. In the first step, eliminate the null variable. So null variable is s gives null, and if we substitute here remains, so s only the null variable. S gives a s b, and first to write as it is a s, b gives s b s, a b b. After that substitute epsilon, remaining is a b, substitute epsilon, remaining is a a. Here write first, here write a itself, okay, write as it is. After that substitute, then a. Next sb, if I substitute this epsilon, then oh sorry, I need to substitute for, okay, correct, s, right, s is a null variable. So if I make epsilon, then remaining bs. If I make this epsilon, then the remaining is sb. Both are epsilon, then remaining is b only. Okay, this is the first step. And in the second step, remove unit production. Is there any unit is there? So yeah, a is the unit. So s gives a, sb, ab. Next a gives aas, aaa. B gives SBS. In the place of A, substitute AAS, AAA, and BB. After that BS, SBB. Okay. In the third step, remove mixed production. S gives S gives ASB, and here it gives AB. No mixed production is there, and here small letter a is followed by the, so A, AS, AA. Okay, here need to change as A not A. After that, next one is B. So S, B not S, A not AS. Next one is A not A. Next here B not, so B not is SB not B. Okay. Next A not means A. Next B not means B. In the fourth step, we need to remove long production. Long means what? Only 2 capital letter required. A, here 3 capital letter are there. M1, AB is fine. S producing. Next A not, AS means consider as M2. A not A is fine. Next B gives S, B not S means consider some M3. A not AS means M2. A not A is fine. Next B not B, 2 caps also fine. Next B not S, B not B, A not gives A. Next B not gives B. M1 means SB, M2 means A S, M3 means B not S, and 8C is also same to convert into CNF. So yeah, S gives 0A 1B and A gives 0AA 1S 1B gives 1BB 0S 0. In the first step remove epsilon production but no epsilon there, leave it. In the second step remove unit production, is there any unit production? No, leave it. In the third step remove mixed, here mixed is there, here also there. So S gives T naught A and T1B and A gives T naught AA, T1S1 and B gives T1BB, T naught S 0 itself, T naught gives 0, T1 means it producing 1, and fourth one is remove long production. Where is long production? Here is long production. S gives T naught A, T1B, T naught M1, T1S1, B gives T1 M2, T naught S 0, T naught gives 0, T1 gives 1, M1 gives AA and M2 gives BB. Okay, this is the final answer. And after that 9 ABC, 10 ABC. Here the question I solved in module 5 itself, and theory question I will give the solution. Okay, and one more thing I need to say. Okay, in the minimized DFA I will write the solution this, correct? So you can see that from A and G H is unreachable, correct? All other states are reachable but H is unreachable. So in the final diagram, first to write this, after that remove H and mention that H is unreachable from starter state, so it can be removed, and the minimized DFA is only this much. Okay, no need of mentioning H. So thank you, bye bye.